And welcome back to Procedural Systems for Production in Cinema 4D. Today we'll be moving on to Lesson 2 and looking at base systems and approaches and best practices for working procedurally within Cinema 4D and how to basically instance different geometry to affect a variety of different setups to begin our research and development process for the project. And we'll be looking at how to utilize fields in Cinema 4D R20 to drive the different changes to our system and how we can utilize the fields to affect different things like polygon selections, shader changes, and deformers, and begin to use those things in conjunction with each other to come up with some unique effects. And we'll be kind of taking advantage of this phase in our project to really dive into our research and development that can then be implemented down the line in our design phase. And some other things we'll be looking at is best practices, again, in terms of smart parent-child relationships, the importance of hierarchy, and really the benefits of using this approach within Cinema 4D. Yeah, so really excited to dive into it. Let's take a look at our first scene here. All right, so jumping in here, I want to first show what we will be building towards in terms of the different setups and best approaches and best practices for working procedurally in Cinema 4D. Currently, we have a handful of setups here, and the spherical field, which is driving different parameters and different effects for each of them. We have this base geometry, which is actually being instanced throughout all the setups, and we'll kind of go over how we're approaching that. But let's take a look at the different setups that I created to show off the range of flexibility and the range of effects that you can arrive at in terms of driving this all procedurally without having to bake any geometry, keeping all the geo parametric, and allowing a lot of flexibility and adaptability when designing and concepting for your brief. Okay, so what we have here is this spherical fall-off being the primary driver for the different parameters that we're affecting across these setups. And these are just a handful of implementations of this approach that I came up with, but we can drag this along and get a sense of what we have here. So the first being taking the base geometry, which is from this instance geo, and extruding the individual polygons and smoothing them out for this nice kind of cushioning effect. And then as we pull it along, this next setup is actually fracturing the individual polygons apart, rounding them out and extruding them. And you'll see it's kind of cool the way that these will snap back together into one piece as they move back along. The next here is taking that same instance geometry and creating this atom array from that geo, and then fracturing it apart to be able to drive shader changes. Right now we're just visualizing this as black and white, but then we can pipe this into our render engine of choice to drive different material changes, different color changes, whatever we may like. The next here is pretty straightforward. It's essentially displacing the geometry for this kind of nice cloth wave effect as we pull it along. And then actually showing how we can clone geo onto our base geometry, using that as the fundamental base to clone different objects onto the vertex of, and then targeting those individual clones towards the field itself as we kind of drag it back and forth as well. You can see it's targeting towards it there. This next one here is actually cloning this same geometry across into a grid array. So using that instance geo, which looks kind of similar to the fracture here, but whereas this is using one instance of the geo and fracturing up the individual polygons, this is actually cloning multiple of each version of the geometry, and then from there we're essentially doing the same thing of extruding it and adding a nice little bevel on the edge. And the last one here is using the field to drive color changes for Verneuil fracture effect, which is being driven by spline to get this nice kind of mathematical fracture across the board. So let's dive in and start to get a sense of how to create this. But before we do that, let's look at this. So right now, because we are procedurally instancing the same geo, it's actually pulling from, you'll see here I have this null called instance geo and the plane inside there. So first thing we can do is maybe change the number of segments that we have. So we'll just up these number of segments. And now when I pull this through, you'll see we have increased resolution. The only one, you'll see here, this one hasn't updated. There's actually a bug with Cinema 4D, or how it basically stores the data, as it's kind of retaining that data without updating it. So you kind of have to force an update by canceling this fracture and then re-enabling it again, so it stops storing the past data in there. But now you'll see we have the increased resolution. This one you won't get a huge sense of unless we change the display type. You can see the increased resolution. And as we drag this along, you'll see we're getting, because we're cloning onto the vertex of this base plane, you'll see we'll get additional clones for increasing that polygon count. This one won't change because, again, each individual one of these is actually cloning the main base. So we'll have to change the display here to see that it's increased geo. And just to illustrate that, let's go back to 4 and 4, and you'll see it's actually adjusting there. And again, this Verneuil fracture won't change much because you're getting an increased resolution of the plane, but it's using the same spline to fracture up that geometry. You'll get a greater sense of some of these changes here. If we drag this back along and come back to the beginning here, and we can, again, since we're using this null, let's first switch this plane back to 4 and 4. We can begin to swap out different geo into this instance for different effects and not have to change anything across the board. You'll see this one again is retaining the instance, but let's toss in a sphere. We'll enable that, and let's refresh our fracture there on the third setup. Collapse these down, and you can see how powerful this is because you're not having to make changes for any of these setups. You can have one setup, and especially as we start to begin to layer these on, it's really important to reference the same base geometry just to make it really flexible, really adaptable. And as we drag this along, you'll see this first one, same effect, extruding there. And this one's actually breaking up. And actually, yeah, you get some really cool kind of curvature forms here as these snap and break apart. And you can, if we're actually animating this, you can add a delay to that or smooth it out so it's not just a quick snap, but this is actually kind of cool. And then the next one here is taking that geo and allowing for shader changes for the atom array and our displacement, cloning and targeting towards our field, cloning a bunch of instances of that geometry, and again fracturing the geo here. So you can start to get a sense of how powerful this approach is and how flexible it allows you to be. We can, throw another piece of geometry in here. Throw a torus in. And kind of take a look here. Some nice tubular effects in the center here. And obviously we'd have to tweak some of these. Some of these are not now working too great with the different geos, so you can tweak the individual systems for whatever piece of geometry you're using, but the speed and basically offloading a lot of manual tasks that you normally would have to do yourself to allow the computer to kind of do what it does best in that regard is a great approach to how to use the work. So let's start building this out. We'll start from scratch and begin to build out all these systems. You can get a sense of how to implement this and hopefully come up with some of your own ideas for the different setups of how we can work procedurally, because we're limited in some regards with obviously Cinema 4D not necessarily being a procedural program and not being node based. There are some aspects that you can affect without breaking down the geometry, most notably vertex tags, point selections, anything that requires you to actually make the geo editable and not parametric. You can't unfortunately have instance geo in that regard and have live updates down the chain, but there are a lot of things that you can do and some nice approaches that I haven't seen many people take advantage of. So I'm really excited to share this with you guys. So let's jump into a fresh scene and we can begin building out these different setups. All right, so jumping into a fresh scene here, and we can just start off with grabbing some geometry that we can use in our various setups. And what we want to do is create a null, and we'll put our geo into the null, and we're basically going to use this as a reference point for all our instance of this geo moving forward for the different setups. So we can call this instance geo, and from there we can grab an instance of this null here. So then anytime we swap what is inside this null, this instance will update across the board, compared to if we grab this plane itself. Then when we build out all our different setups, we'll have to drag and update all those things. So we're using this null as kind of a casing to hold whatever geometry we'd like to put in there. So we have our instance geo here, and we can begin kind of building our first setup. So what I want to do is grab a MoExtrude to show off setup 1. And we can make this a child of the instance, or we can just throw these both in a null. So let's do that. And we can call this setup 1. And we have a little bit too many segments for that, so we'll jump back into our original plane. And let's drop this down to maybe 4x4. And we'll have to tweak some of these parameters here for our MoExtrude. So what I want to do first is change the extrusion steps back to 1. And let's tweak this a little bit. We can drop this to maybe 0.7 for the scale across the board. And let's bump this up rather than 5. Let's make it 50. So we have this very low res geometry that we're using, and we want to smooth this out. So let's grab a subdivision surface, and we can toss this in. Let's put these both within a null. Just clicking Alt-G to throw these into a group. That's smart use of parent-child relationships, and rather than making things, especially when you're instancing geometry and you're trying to create setups that reference back to each other, you have to be somewhat tactical in how you group things and how you make things parents and children of each other. So we'll just make this, let's call this MoExtrude. And let's throw that in the subdivision surface. We'll crank this up just to smooth it out a little bit. And now we have this pretty nice looking little bubbly surface. But what we want to do is animate this, and we can, in the MoExtrude, use effectors to drive. So especially with R20 and fields, it kind of renders all the other types of effectors mute, because essentially all you really need is a plane effector across the board, and you can essentially handle everything in the fields itself rather than various different types of effectors. So we're just going to use a plane effector for pretty much most of the use cases here, and what we want to do is offset the transform that we have in the MoExtrude. So right now it is moving up 50 centimeters, and so we want to offset that. So let's do -50 here, and now we're back to our original plane. And under this driver here, we're going to add, let's just do a spherical field again, We can drop that in, and we'll need to tweak this a little bit. We can adjust the inner offset just to give us a little more of a sharper fall off here. And we want to invert it, but I don't want to invert it just, in the field itself. We can actually, if you can actually invert it and do it that way. But we want to do it on basically a per setup basis. So rather than that, let's just add, you'll see within the fields, a really nice aspect is all these modifier layers. And these are different modifiers that you can affect. So we can just throw an invert on top, essentially. And we don't need color, but it doesn't really matter. And invert it that way. So then anytime we're utilizing this field, it's essentially the same base. And if we want to invert it, if we want to tweak it, if we want to change the remapping, whatever we'd like to do, we can do it within basically each setup rather than universally, because we're going to use the spherical field across the board. So let's actually drag the spherical field out, and we're starting to get our setups here. So let's put this, just get proper hierarchy here. And now we have, let's move out here, make this a little bit bigger. And now we have the ability to animate this Mow Extrude with the spherical fall off. And again, we're utilizing this instance geo, and we can begin to use that same instance geo for various setups. So let's do that. We'll grab another instance and create our second setup here. And what we'll do is offset this, this time by 400. Let's grab our second instance here, and what we'll do is offset this by 400 here. And now we have another setup. Let's drag this down. We will throw this in a null, and we can call this setup 2. Now for the second one, I wanted to show how we can actually, fracture out this geometry into individual polygons and then affect those polygons however we'd like. So what we want to do is we have the instance geo here, and let's grab a polyeffects. So grab that. If you want to see where it's at here, it's just in MoGraph next to the Mow Extrude. And again, we can either make it a child. We're actually not going to reference this down the chain, so it doesn't make a huge difference. But yeah, we can just make it a child here. And what we want to do is fracture out those polygons. So you'll see that this actually will do that for us. And utilizing effectors again, we can drive that ability. So let's grab another plane effector. We can throw this in the chain. Make sure this is in our effector stack, which it is. And let's turn off position. We don't want position, but we can use scale. And for scale, let's shrink this down -0.4. Looks good. And now you can see we are fracturing out the individual polygons and are able to affect them here. With the plane effector, for our fall off, we can drag back in our same spherical field, and now we have the spherical field driving the fracturing. To make this a little bit more interesting, we can add a couple more things. What we want to do is perhaps add a bevel just to get a nice, and just put that in our stack here and start to tweak this. And we won't get a great sense of how this is being affected until we start to extrude this. So I'm going to use a cloth surface for this instance and throw it in there. And we will go in the cloth surface and add some thickness. Maybe 5 will do it, or maybe let's try a little bit thicker just so we can see it. I think 10 looks pretty good. And now we're able to add extrusions to the individual polygons, which is nice. So let's go back in and tweak our bevel here. We might want to do points actually. So rather than beveling from each edge along here. It's actually going to bevel from each point in between. And so you get a nice effect there. And I'll actually throw this, in addition to the cloth surface, we're going to remove the subdivisions of the cloth surface. We don't need that. We're using it just for the thickness. And I'm going to grab another subdivision surface and put that in there before the cloth. And now you get this nice rounded edges there. And if we drag this along, you'll see this kind of starts to nicely snap apart as it moves. And we're able to affect individual polygons. And we can actually, change, because we're separating them out, we can drive color, drive different shader changes, whatever we like to do with those individual polygons. And as we go through and look through these different setups and these different systems that we can utilize, you can start to get a sense of how we can compound upon them and iterate upon them and use them in conjunction with each other to get some more unique setups. So these are kind of just base foundations to give you an idea of the possibilities, and from there it's really up to you to how you implement them in your own work. But let's move on to the next setup here. So we have our first one, extruding nicely. We have this one here basically breaking up our individual polygons. And for the next one here, we're actually going to fracture out a atom array to be able to drive different types of colors. So let's do that. We can collapse this down. Got setup 1, setup 2, and we'll grab another instance of our geo here, and this will be our third setup. And we can throw this in a group and rename this setup 3. We need to offset this by 800 this time to give us our nice spacing. And this one should be pretty straightforward, actually. We're just going to grab an atom array and put our instance into there. And this will allow us to basically outline our geo here. So I think I'm going to use a bevel again just to show how you can take this base geometry, which is nice, and then affect it in a lot of different ways before you then affect it down the chain as well. So here I'm going to go to points again to offset from the points, and we can get a nice little pattern. I will drop the sphere and maybe drop this cylinder amount just to get this nice little stitching. And you can layer these on, so we can do multiples to get some interesting patterns, and maybe make this one edge and do this prior. So then we kind of break up the edges and then are able to offset those points from those edges to get some cool effects. I think that'll work for now. And we want to drive color through this, which is actually something that we'll use later in the course as well. So what we can do is grab a fracture, and this will fracture out our geo. And under here, you can see the primary modes of the fracture. We have just straight fracture or explode segments, which we would like to do. So we're going to explode the segments, and now we need to drive the color. So how we can do that is, once again, our trusty plane effector. It's very multi-use, and we're going to turn off position. Under color mode, utilizing field color, which is good. But one thing we need to do is under the fracture, under transform, it's actually giving it a color already. Right now it's making it white. We want to make it black, so we can do that. And here, under the plane effector, let's drag in our spherical fall off. And once we drag that in here, one thing we haven't done with the spherical fall up is set up the color. So under color remap, it kind of just assigns a random color. We want to make that white. And now we're using our spherical fall off to drive color. And we're able to do that because we're fracturing apart. If we didn't fracture this into individual pieces, you'll see you're not actually able to affect color here. So the fracture is allowing us to take this geo, which is actually pretty cool because we're referencing this original geometry. We're beveling it, so making some procedural changes to it, piping that into an atom array, which is able to generate this pattern. Then we're able to fracture that pattern apart into its individual pieces, and then utilize our fall off, or our field, sorry, to drive color, which is pretty cool. So that is our third setup here, and again, we'll be using this one later in the course as well. So it's a good one to hold on to. Let's set up our next one. So we can grab this instance geo and create another instance, and this will be setup number 4. Let's name this here. Cool. And let's offset it where we need it. What was the last one? 800. Okay, cool. 1200. There we go. And with this one, pretty straightforward again. We can just grab a plane effector. We'll make this, we're actually going to use this not as, a driver in terms of fracturing out or individual pieces of geometry, but we're just going to go to the deformer mode, and in the deformation, we're going to deform it by point. And right now, it's going the wrong direction. We can actually pipe it up this way, and maybe let's do, 150. Might be a little too high, but we'll see. And that is, kind of the bulk of this setup, actually. And from here, we can just drag in our spherical field, and now we're able to use the spherical field to offset the points, or deform the points upwards using plane effector. So that's pretty cool. What we want to do is throw this again in a cloth surface just to give it some thickness, and we can subdivide it using this. So maybe 3, and for thickness, maybe 5 again would be nice. And the cool thing about the cloth surface is if you subdivide using the cloth, it actually retains, doesn't smooth all these out perfectly. So it actually, you get some nice quality with your deformation, that if you used a subdivision surface, it would smooth it out a lot differently. So I think here, let's actually tweak our field a little bit, and yeah, we have a nice point deformation driven by our same spherical field. Cool thing is we're just building these up upon each other, and right now we're just offsetting them to give a sense of all the different effects that you can generate, but you can use these on top of each other, if all these instances were in the same place, and having this atom array actually outlining some of these instances and changing colors, these fracture out, and then another layer on top is pushing up and creating a bulge there. So you can start to understand how these can be used in a larger system in conjunction with each other, and become really powerful, and end up saving you a lot of time in terms of not needing to make manual changes, and just being able to swap things out and try things out and build one system that you can then utilize throughout your process without having to do a lot of manual changes that aren't necessary. So that's the next setup here. And the one that I want to show you after this is how we can kind of use that base geometry, whatever it is, as our kind of housing for cloning different objects onto it. So we can collapse this. We'll grab our instance geo and grab another instance of it. Same thing, we'll throw this in a group. We'll call this setup 5. And we can offset this. And there we go. We got our next setup here. And with this one, let's clone some geometry onto it. So we can grab a cloner. I'll probably grab a cylinder again. It works pretty well for the showing the directional changes. Let's zero this out, zero that out. So we're in the center here. Adjust the cylinder a little bit. We can make it the radius a lot thinner and maybe half the height here. What we want to do is change this from linear to object mode, and we can drag in our instance here to clone onto the instance, which is pretty cool. And we're going to change this through for the distribution. You can do edge and again start to get an outline, which can be useful. Polygon center. But what we're going to use is just the vertex here. So it'll clone onto each of the vertex points. So what we're going to do is we want to have them all orient themselves to the field. So as this field kind of changes and moves throughout, the clones orient themselves. And we can do that by grabbing a target effector, and under the target effector here, we want to choose our target object, and that's going to be our spherical field. Right now they're not oriented correctly, so let's change that. We can flip this. There we go. See if, yeah, they're both actually kind of cool in different ways. This one you get a nice like circular pattern, but this way it's actually, you know, pointing towards what we're looking for. So again, in the target effector, we brought in our target object, which we can make actually a field if we'd like. And you know, we could also use the fall off. So if it's outside of this point, it is not, you know, being affected by the target, but kind of like how it orients over time. What we do want to do is I actually want to scale these down when it's outside the radius of the spherical field. So let's clean up our hierarchy there a little bit. But I'm going to grab the cloner, and we're going to grab our trusty plane effector again. We can put this there. Under parameter, I'm going to get rid of position. I'm going to check on scale. We'll turn on uniform scale, and we'll just make it -1 just to get rid of it there. And under the fall off, we'll drag back in our spherical field. And currently, this is the inverse of what we want. So we can go back into the plane effector, fall off, and let's add another invert. Now, as we drag along, you'll see they'll kind of appear. And let's make this a little bigger. They'll appear and orient themselves towards the spherical fall off, which is pretty cool. And you can, you know, again, this is kind of a base setup, and you can start to think about how these come into play with different aspects of your system and how these can layer on top of each other, and how you can, you know, instance multiple sets of geometry and start to clone different objects and have those objects be connected or affected through different ways. And you can build some pretty complex systems that are all procedural and all kind of referencing each other and updating themselves down the chain. So yeah, the next setup that I wanted to talk through here is for taking this kind of base geo and then perhaps cloning a grid of those that you can then utilize in a variety of ways. So just kind of walking through a handful of the different use cases of this approach. So we'll grab another instance of that reference point that we have available to us. And I'll grab a cloner, and we'll throw our instance geo into the cloner here. And what we need to do is throw this in a null, and we'll call this one setup 6, and we will offset it. What was the last one again? 16. Okay, cool. 2000, and we have it here along the chain. And for this one, we're going to go into Cloner. For the object, we're going to change it from linear to grid array. We don't want any along the Y, just along the X and Z. And we can set this to per step. So the size increment is per step rather than an endpoint. And under the transform, we can scale these instances down. So maybe let's set this to 0.25 for now for all of these. I think that looks good. And then we can scale these out. So maybe 125, 125. You start to see our array of our geo there, which is useful. And we can then begin to utilize these in a lot of different ways. We can color them again and do some material changes. We can affect them individually and be able to swap these out at will however we'd like. So let me tweak this a little bit just to get it where we'd like it. Cool. We have a nice little grid here. And what I want to do is I'll grab another cloth surface just to get some thickness to these. And what we can do is actually throw this way. We'll just need to zero those out and just do one across the board and then clone those individually. Turn on old gene just to get a little tapered edge there. And there we go. We got our, smooth these out, kill that there. Nice little tiles here. And let's maybe just rotate these. How I had this originally set up is they just rotate as the spherical field passes through. Rotate these along the Z. You can just do 180. And under there, we're going to drop in our spherical field once again. And so as these travel along, they kind of slot and change. So yeah, you can get a sense of actually just rather than taking one piece of the base geo and doing different types of deformations on it or affecting it in different ways, you can just take multiple clones of that base geo and affect those as well. So I thought that was important to include just to give you the range of abilities with this. So let's jump into the last setup we have. And so we'll grab another instance of our geometry, kind of same thing. We're going to throw it in a null. We'll call it setup 7. And we'll offset this to get it where we need it. And what we're going to do with this one is show that even with this instance geometry, we can actually fracture it as well. So grab a Verneuil fracture, throw this in. You see we can actually fracture out our geometry here. What I want to do is change what our source is. Right now it's just kind of random point generator. It's generating all these points, which are then using to calculate how the Verneuil is fracturing. But what we want to do is perhaps we'll use a spline as the input for the source. I could put that in our setup, zero that out so it gets where we need it. Rather than XY, I'm going to change it to XZ just to lay it out and have it outline our plane here. Now under the Verneuil fracture, we can drag in our rectangle, and you see we get this cool, more kind of mathematical pattern rather than just like a random generation. And you can do a lot of things with this. You can round it out to get a cool effect there and turn that off. And what I want to do, I'm going to turn off colorize fragments. Don't want to colorize them. We're going to actually use the spherical field to drive color. So once again, we grab a plane effector and throw this in here. And I want to turn off position. And we're going to use fields color. That'll work. We're going to change the color again to black rather than white, just to make sure that's not affecting anything. And we can drag in our spherical field. So right now this is driving our color as we go along. Actually, kind of liked the randomization of color that it was getting on the base. This is a cool effect, but I'm going to try one other thing. We can go here, go to our plane effector, and let's just drop in a random field and turn off that here. And we'll set this, rather than, because we already had this field in here, this defaults to max. Just set this to normal. And then under the color remap here, we can set it to, rather than a single color, set it to a gradient. And now we're getting a randomization of color from black to white, which is pretty cool. And then under this here, I actually want to center this, just so bring this over here, and then we can hide it, put it back in. But rather than just have this standard field, we can actually use this spherical field to reveal it. So what we can do here is set, we'll put the spherical field at the bottom, and for the random field, we'll set this back to max, or min here actually. And as we grab our spherical field, you'll see now the spherical field is kind of the base, and the random field is affecting only where the spherical field is kind of dragged across. So now we have this black plane, and as we drag the spherical field, it kind of reveals the pattern underneath. But you can also just get rid of that and have the spherical field itself driving the color. It's kind of like the randomization in here rather than just the flat white is a nice little touch. Yeah, and that is our kind of main setups that I wanted to showcase here, and we'll be building other ones and kind of iterating upon these as we move forward in the lesson, but in the course. But yeah, this gives a nice foundation in terms of approach of how to work procedurally. And again, since we have this instance geo here, we can change whatever we'd like, and it just live updates. So maybe we just have 2 instead, and we'll have to refresh the fracture, unfortunately. But now we have just 2 across the board. These are not utilizing the individual polygons, so that doesn't make a difference. And this kind of loses all effect with less polygons. But we can toss in some other geo. So let's just delete that. We can get rid of that fracture. I'm going to hide this rectangle. And let's grab something else. Maybe grab a disk and put that in there and redo that fracture there. We'll have to drop our segments a little bit, and we can start to see how this comes to life. Let's scale this up. We'll refracture that. And you can see how you can just play around and really quickly try out different setups without having to rebuild all of this or make a lot of changes with that are unnecessary. You can minimize the manual work that you have and really just have fun once the base system is set up, which is really cool. So that'll do it for this lesson, and we'll, in the following lesson, begin to implement a lot of these systems, a lot of these techniques, and begin to figure out how we can use these this research and development that we've done so far and implement that to generate a series of designs and come up with our overarching concept in response to the brief. And yeah, I'm excited to begin to utilize these in a variety of different ways and begin to build out our design language and our different kind of overarching systems that then we can use in our direction for the concept. So yeah, thanks so much for joining me in this lesson, and I look forward to seeing you in the next one. Take care. Hello, everyone, and welcome back to Procedural Systems for Production in Cinema 4D. In this lesson, we'll be building upon some of the techniques and approaches that we learned from the last lesson and start our design phase, begin developing the design language and the various systems that we can use for our foam, our cushions, and our stitching. We'll start some look development and explore various style frames that can help respond to the brief. And we'll be building upon that design language to start concepting for our first shot. Once we dive into that first shot, some of the techniques we can cover is creating different subsystems and a procedural set of relationships that we can utilize throughout. And we'll begin kind of creating different layered elements by manipulating instances of our base system. So really excited to start diving into the look development and design language phase and begin building out from there. Before we start diving into cinema, let's take a look at our brief again and see what we're building towards and make sure we kind of refocus ourselves in terms of responding to some of the various points throughout the brief that we need to touch on. So let's take a look at that quickly. So jumping back into our brief, we can take a look at some of the benefits and some of the concepts that the client would like us to convey. I think we did a good job in gathering ref that can help us throughout the process and get a sense of how we can tackle some of these various product points and benefits that we need to cover. And I think it's a good thing to stay focused throughout the exploration process, but not to be exclusionary in what we come up with and really keeping an open mind throughout, especially early on. And as we kind of move throughout the process, we can begin to funnel that down and refine towards a specific shot or a specific concept that we're looking to convey. So let's take a look quickly at our reference once again, just to refocus ourselves and get a sense of the different aspects that we need to keep in mind. So for the feeling, again, just to briefly retouch